Go.
Okay, well, we're starting. Welcome to my little talk that I've been making for over a year and should have been done a year ago. I'm talking about how to build large-scale applications in AWS, which is Amazon Web Services. I'm talking about Rokka mainly, but just in how we use AWS Rokka. So building something large is very easy, but something that scales large is slightly harder. And if you use AWS, that can help you. And much better. So, what are you expecting here? Let's talk a little bit how we engineered Rokka to be what it is today, the components that are used in Rokka, and how those components work together. So, I'm not overloading you with all of it in one go. A little bit of pitfalls that we encountered when we were doing this, and yeah, what we're doing in the future. Oh, in the future, AWS. Concepts, okay. About now, is that better? Oh, it looks good. Right? How about this? Are they happy now? Well, okay, I'll just continue and
Just continue and I'll do.
Okay, so what I'm not going to do is I'm not going to show you any code, I'm not going to show you any command lines, and there are a few pictures waiting on other ministers. So first step, engineering. What do you need to make Rokka work, and what do you want in making Rokka work? So images, right? Everyone has that problem. Then we need to store the images, we need to store metadata about the images, we need to render the images, and we need to distribute the images. So our solution is very simple and straightforward. Images use image magic, store the images, use Amazon S3. For the metadata, use DynamoDB. Then,
Detail broadcasting your sound.
oh, good. Does that work? I don't know.
Yeah.
I guess it works. Okay. Good. Where was that? Here. Is it short? Yes, it is. Good. Is this better? So I'm sharing the screen again.
And then the settings.
And setting, it's all there.
Save.
Okay. Good. Can anyone hear me? Does that work? So now my site says it does nothing.
Hello? 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 Hello?
No, that says nothing. Yeah, I can't hear you either, whoever is speaking there, because it's too much black. Okay, good. Then no problem. Lots of problems. Okay, so to recap for the other offices who haven't heard it, we just want, you saw the slides, I guess, so you probably have an inkling of what we're doing. So I just explained what we're doing with Rokka and what we wanted out of all of this. And now let's look at the individual components. So these are the individual blocks from AWS that we're using. So I'm going to throw lots of words at you right now. We're using something called Beanstalk, which then in turn uses EC2 and load balancer. This is the equivalent of Heroku or Cloud Foundry or something like that from Amazon, which is a platform as a service. So you go choose the language, PHP in our case. You say what type of application it is. For us, it's a web application. And then you have a single command which is deploy. And that's deploy, the whole app gets packaged together, it gets uploaded. And at that moment, everything else runs in the background. You can close your command line if you want to. What that does is it creates the instances, the individual instances behind the scenes. It creates a load balancer, wires it all together. The whole thing supports rolling updates, so you can do it without, you can deploy or update instances without any downtime whatsoever. It does health checks, so it knows when something went wrong. And if something fails completely, then it will revert to the previous version it had that worked. And of course, the great thing is it scales automatically, which you can configure when and under what conditions and how many maximum, how many minimum you want. It restarts that instances for you. And what you do is you pay by hour of service running. So you have 2 servers running 24/7. That's good. And then if you just have one running for 2 hours because there's a lot of requests, then you just pay those 2 hours on top of that. S3, simple file storage. We just use it basically as a file storage for the source images, the original large images that they're uploading, plus a little bit for some cached images. We're using a library called Fly System, which abstracts that for us, and then it doesn't matter if it's S3 or if it would be local file system or an FTP server, we don't care. It's just the same for us on the code side. You pay by gigabyte used per month, but you also pay by access. So if you have lots and lots of accesses, that can also be a cost you have to be aware of. So using some caching mechanisms, you can make this a little cheaper. And we have a replication setup that automatically copies all the data of the source images to another data center in case, I don't know, a meteor hits Frankfurt or something. But overall, it's very cheap, so it's not that expensive to do it doubly. And it also enables static file hosting. I'll come to that in a little bit later. DynamoDB. It's a completely managed database. You just access it over an API, and you pay by maximum amount of throughput. You do concurrent reads and concurrent writes, plus the data you save. Again, data storage is cheap. You can do some filtering, but this is not a relational database. It's more a document store. So it's very great for primary key lookups. You say like, oh, I want this image with this hash, and it throws it at you in milliseconds. It's really great and really, really shitty for anything that you do with searches. When we started using it, there was only an option to use their special format. So we had to use that, and we created a transformer or serializer, whatever you want to call it, to make the PHP objects we had into this specific format. Well, in the meantime, they're supporting direct JSON, and they also have a new serializer, but we're not using it yet because why touch the running system, right? There's also no migration at all in this. So if you change something, you have to work additive, and you have to assume that all the new fields that you create are null on return. CloudFront, the content delivery network of Amazon. Worldwide access nodes, all the fancy stuff. You can allow very specific caching rules, like say, oh, the server says when and how long to cache it, instead of CloudFront deciding when to. And you can invalidate cache objects, which we are also actively doing in some cases. You can have your own domain, so it's all on Rokka.io. Then all the images, the website, all of it is sent over HTTPS always, and we're using HTTP 2 with the fallback to HTTP 1.1 if someone still uses Netscape or something like that. You pay by bytes sent out from the nodes of the network. Internal traffic is actually free. Yeah, that's not everything. There's also Route 53. It's the DNS service. It can do health and geolocation magic for you. So if the endpoint that you're pointing to is no longer healthy, it can detect that and then not say, go to this endpoint to the end user who comes there. Very useful for disaster recovery or things like this. Or also, oh, there's a closer data center where there's also an instance of the app running, so that's faster. It supports IPv6, thankfully, so we're doing that as well. The wonderful creatively named Cloud Search. We're using this for listing of images. I'll talk a little bit later how we do this, but all the image metadata is also in Cloud Search, so we can search, because DynamoDB is crap at that. This is not Elasticsearch. They also offer Elasticsearch. This is purely Solr based and also completely managed, completely hands-off. We just have an API like with DynamoDB. Then Elastic Cache. Their offering is Redis and Memcache. Naturally, we use both. And we're trying to get away from one of them, so because you pay per cluster you're using. And it has cluster support. So one node goes down, everything is still there. But it's just cache. If it all goes to hell, we don't care. It still works. Sort of. We're just getting away from that. There's a bug in there. And you pay per month and per size of machine you want, how many gigabytes of RAM you want in there for the cache. CloudWatch. This is the collection of all the logs that we have. The instance CPU usage, memory usage, requests made, how much data using S3, how much CloudFront has piped through. All of it goes all in there, and it all collects it together. You can also have your custom log sense, for example, our Symfony application logs, which is very handy if you have 3 or 10 instances and you don't know in which one was the error. It just goes all into one bucket, and you just select it in there and search it. Lambda, the serverless thing. What you do is just you upload code. In our case, it's JavaScript. They're also supporting other script languages in the future. But right now, that's what we do. And then you pay by runtime, and it's actually calculating by 0.1 second increments. So if you want to do something very long running, don't use Lambda. It's not really good. But it's nice for these little things that don't have to have much complexity around them. You can trigger it by internal events. We'll come to those later, or by direct API calls. Email, simple email service. Very handy acronym. Just email. You pay by email sent, and we're sending out welcome emails when you register, and we send usage warnings over this. Yes, you are there yet. So now, how do we use that in Rokka? Let's go through it. So first off, we have actually two applications, sort of, actually more applications, but the main application is the renderer and the API. Now, this is one Symfony application in one repo, but it gets deployed twice as separate applications. Once you have the API, that's directly accessed through the load balancer. That's for uploading images, managing stacks and users and all that stuff. And on the other hand, we have the renderer, which then does the actual image manipulation, resizing, converting, and then that's sent out over CloudFront. We're doing this to protect both rendering and API. For example, someone uploads 1 million images or tries to upload the same image 10,000 times per hour. Then the API can be a bit slow, but the rendering is still lightning fast, and nobody will complain about it. So, user registration, API call, we send an email, hello, I'm Zone SES. Organization creation, the next step, right? So in here, we get the call, we save the data in DynamoDB, and then we create what's called a distribution, which is the something.rokka.io endpoint on CloudFront, which then goes back to the renderer. And then we also created DNS entries in Route 53 so that it points to that CloudFront distribution. Image upload. We upload an image, save the original data in S3, save the metadata in DynamoDB. And now it gets a little tricky. As soon as we save that in DynamoDB, it sends a little event, an internal DynamoDB event, to Lambda, which triggers that Lambda function that then takes that metadata and also adds it to Cloud Search. So then we can search in the images. So when we list images or search in them, we look up in Cloud Search, get all the IDs together, and then we get the data out of DynamoDB. Actually, I think that's wrong. We changed that, and we're now completely getting it out of DynamoDB. Yes, Riesen is nodding good. So that's how we do it. But that's also a way you can do it, actually. That's a best practice that I've seen as well. So both of it is perfectly valid, but you can do whatever you want in there. Okay, rendering. A little bit more complex. First, when you render an image, you give it the hash and the stack in an organization. So we look up the stack in the organization, we check, is it in the cache? And if not, we get it from DynamoDB and put it in the cache. Then, based on this, we check the memory cache and an S3 cache we created, if that rendered image with those parameters already exists, and throw that back otherwise. If not, no cache. So we go and grab the actual source images for that organization, and then render it according to the stack. Now we have the rendered image, so we return that to the client with low caching time, about 5 minutes. The reason for that is the next step. Now we save that rendered image also in the caches. And you're writing to the S3 cache, and that again has an internal event that calls a Lambda function. And that Lambda function then optimizes these cached images. It compresses them even further without losing quality. But that takes a while. And a while in web terms, that's 2 seconds or 3 seconds. So we don't want to wait the first person to hit it, wait 3 seconds, but they just get an unoptimized image in the first load. But that's fine. Then we have that highly compressed image. We save that into the cache. And then the next person who comes along gets the highly optimized version. And that one has a long cache time of a year right now. Also, that S3 cache cleans itself after 90 days, which is also completely configured inside S3. So we don't have to run a cron job and clean out old stuff anymore. So that's rendering. Oh. Yeah, so Rokka has a free tier of usage. And of course, for that, you have a limit. And if you get close to the limit, we need to alert people. So we have a cron job that checks the traffic limits every hour. And if a user is over the traffic limit, it sends an email once, of course, and then repeats it after 3 days or so. And if you do an upload or a delete, it checks the file usage. So it knows always on time when you do an operation how much you're using, and also sends per email a limit, the warning, hello, you're over the limit. And of course, that data we have there, we also use it to actually bill the customers who are paying for us already. And yes, we do have customers who pay for it. Good. The website, not very greatly exciting. We use a static website generator called Sculpin. It's built in PHP using Symfony components, so it was close for us to use it. The Rokka site itself, the code is actually on GitHub. It's publicly viewable. Everyone can see it. And then when we merge to the master, it triggers a deploy using Travis CI. and we're deploying that to an S3 bucket, which then uses static content hosting to serve it, and then we have CloudFront in front of it, so it's really, really fast. This is very, very cheap and easy solution. It's automatic. If something goes wrong during the build, like you screwed up a new script or something else, the build will fail and it will not deploy. And Travis will complain to you, hey, your build failed. So it's also very nice for you to not automatically screw up your entire homepage. We also have an admin front end, which lives in a completely separate repo. And when that is built and has a new version out, it actually triggers a deploy also on the web page, which is integrating that. So that also works completely automatic. So we don't have to do some merge magic or update a version here or there. Just click, done, and it works. Good. So now it's all taped together, right? So it's running or floating or whatever Janie Heinemann is doing here. Pitfalls. So here's some knowledge that I want to arm you with before you go and run into AWS yourself. Amazon has a lot of ways they're doing it on their own, like the weird format they're using for DynamoDB that was a head scratcher more than once, and produce lots of bugs because we made our own serializer. So you have to get used to that first. There's lots of permission things that are a little esoteric to understand, and it might take a while. But taking that aside, there's always something that says, oh, this is how to use it, or this is the use case you should use it for. And those best practices can save your ass instantly. Just follow them along and then try to deviate if you have to do something different, because otherwise, yeah, you're not going to be happy at all. And if you find something and it doesn't do exactly what you want, you can get around it. But the more you go around it, the less AWS is going to help you, the less performance you might actually have in the end. So be a bit careful there. Now, technically, we can move entire Rokka into another cloud. Most of what we would have to change is the glue code that stitches it together. We have a pretty strong separation between our core services. This is change an image versus this is make an organization in AWS. We have, for example, an event that gets thrown and you call, oh, make an organization. And then that is then translated into call a listener that creates the actual organization on CloudFront and do the DNS stuff and so on. So this separation makes our code much cleaner, also makes it easier to maintain and to test, of course. Yeah. So every time you have to reinvent yourself, the more you go away from what the easy parts is from AWS, the harder it gets for you yourself. So if AWS comes out with a new feature, like now they support JSON or they support have their own serializer that works pretty well, as far as I've seen, that might make it much harder for you to switch to that because you have already your clutch all over your place, all over your code. So it might not be that easy. So be very mindful of that. You might also not be able to use a new feature because whatever you're doing is not so great. So the more you abstract things away, the easier it is for yourself again. So using Fly System for us, it's great. We just had another use case for disaster recovery that just makes it, oh, just slap something else behind it and it's good. Documentation is a very mixed bag. So quality and quantity is yeah, hit and miss. The things that are used a lot that are around for a long time, EC2, S3, you'll find everything and anything for them. But as soon as you go a little bit into the newer things, Beanstalk is almost one of those. It might not be that easy, or how to enable HTTP2 on CloudFront and things like that. That always might take a little bit more, or they're just not up to date yet. Most of the time, it's sufficient to do what you need to do and what you want to. Yeah, but if you can't do that, you usually find a forum or Stack Overflow or something else that tells you, hey, you can just do this and it works. Again, use it with caution. So where do we go next with this? One of them you probably have heard already from Michelle is Amazon Recognition. It's a deep neural network learning engine. Oh my God. That can tell you quite a lot of things about an image. So recognition, moderating, detection, and recognition, which are two different things, very important. So, for example, you can tell, oh, this is a person, and there's a crest in the background, this is outdoors, there's a mountain bike, there's rocks. And the percentages it gives you is how much confidence does it have in that is there. So it might say helmet, or it might say, I don't know, rain, because it could be raining in the background or something. You get very, very general terms back from it. And it's nice. It could also tell you if the person is male or female, if they're smiling and things like that, if you have a better picture of the face. Might be a useful thing, but it's also expensive per image. So we might have that as an add-on service or something like that in the future. Queues, of course, Amazon has queues. Everyone has. One of the great things about this is it has a delay function included. So you can say, send this message, but wait first for 15 minutes or something like that. Can be helpful in many little use cases. It could help us scale easier maybe, or offload certain things. Upworks and CloudFormation. It's a thing sort of like Puppet and Chef and things like that. So but on a broader scale, you say, I want 10 servers and not, I want PHP installed. So it's just taking the whole codify your infrastructure to a next level. And that might be very useful for us. And actually, there's already some version of this running. But yeah, we're still tinkering around with this. Rendering on GPUs. I mean, what better to use to do graphical things than use a CPU that is actually made for this, right? They're still expensive, but I mean, if we scale up even more, it might be much more efficient and faster to do it on GPUs. So maybe we'll use that in the future. Good. So let's wrap this up. Yeah, sorry, I know. No, the song is stuck in your head for the next 2 days. I know what I did, and I'm not sorry for that. So AWS is great for large-scale applications, but it's by far not perfect. When you just want to get into it, it's mostly free. If you just start a new account right now, you get a 1-year free tier that is lots and lots of stuff that you don't pay a single cent for it. It's enough to run a server 24/7. It's enough to run a database instance 24/7. It's enough. You have like 1,000 emails. You have 10 gigabytes of storage and things like that. It's more than enough just to tinker around and even do small projects with it. And even then, after that first year is over, there's still a certain amount of things that are free. The first 1,000 emails in your month history or something like this. Also, the costs are always generated on a per-use basis, so you don't have this fixed cost thing that you have to worry about. So if you just have a little dimple project that just goes around there, it's not going to cost you much. I have one, and I get every month a statement of 52 cents from Amazon. Amazing. The integration between the services is really smooth. It saves you a lot of mistakes and a lot of hassle that you would have to otherwise. So copy this from there, or so just click and it works. And you can optimize the costs by using caching, of course, and something that's called resource instances, which sort of negates the fixed cost thing again. But if you already know we're going to run Rokka and there's 2 servers that run 24/7, you can save 50% or more of your bill if this. And you can even switch, which we found out, between different types of instances as long as they're in the same area. There's like the small and the middle and the large ones. So as long as you switch between different small ones or different medium ones, you can still do that without being completely locked in. Good. Yeah, it's easy. So don't play around with servers, push your code, works. You still have access to the application service. You can still SSH in if you really want to do something or if you need it for debugging or something. But it takes a lot of that away. Deployment is simple. You get a good overview of your health of your application without having to have tons of tools installed. It scales, it replaces instances if something dies. And none of these 3M calls it's down. Can you? No, none of that. So that was it. Thank you for listening. Are there any questions? Nothing? Yeah. Good.
Yeah, one question. So did you start building this Rokka application on AWS from the very beginning? So you had it in mind as a large-scale application from the beginning? Or is it something that you realized along the way that you actually needed to scale, be able to scale that?
No, at the very beginning, it was the way the rendering worked was it actually, when there was a 404, the image is not there, so it renders it and puts it where the 404 thought it should have been. That was the first version of it. So just on the file system. And of course, that doesn't scale because you have 10 instances and they have different file systems. So, okay, that doesn't work. And basically out of those needs to scale it up, then came, oh, you know, what are the components we need? What are the things that we actually need to run it? But also, what are the things we want out of it to run it, so we don't have the 3 a.m. phone call? And then by looking around and testing a couple of things out, Amazon was basically a very natural progression from there.
Yeah, so it wasn't like planned to be that large from the very beginning. You realized along the way.
Was to scale it up, yeah. But to be able to scale it up, we needed to change architecture of it. So, and for that, then we used AWS. Sort of how it came about. Good.
Question, what's approximately the relation between the core logic which you implemented and the infrastructure code you had to do to implement? What are the proportions of these?
It's really hard. It's really hard to say. I can't say it in lines of code or anything like that. I would say closer to 1-to-1, but it depends. We have certain operations are very complex and they take a large class, and then we have the Amazon SDK that does a lot of abstraction for us. So we just say, make this domain, and that's it. So from our view, it was relatively harmless in terms of size that we had to deal with. And then, of course, we also made services and trades and other classes that abstracted lots of that away again and made it simpler again and more compact. But it's really you have the core on one side, and it usually works with a event or something that triggers then the infrastructure side. So we really have that separation mostly very strictly happening.
Is this on?
I think so.
Okay, cool. I hope this isn't too much of a Rokka-specific question, but you said you're currently running Memcache and Redis clusters, and you want to get rid of one, but you didn't seem very sure which one. Yes,
it really doesn't matter that much to us at the moment. We just haven't gone around to look at it exactly what we would get rid of and what not. But for us, it doesn't matter that much, really, at this point. We use them as caches. So it's all data that can go poof away. Redis is more, Memcache is more the thing cache and throw away, but Redis can also be persisted and almost used like a store like DynamoDB. You know, depends on your use cases. For us, it doesn't matter that much.
Thank you.
Have questions from other offices?
Yes, there's a question in Burn, but I can't figure out how to unmute it.
Or just, can you write in chat or something?
Trying to see the replies.
No? Burn, can you write it in chat, please? So, in the Liip Talk channel.
Type. It's terrible. It's hard. Oh, there's one from Christoph Leinberger. AWS used to be pretty user-friendly at the beginning. Has that changed? User-unfriendly. User-unfriendly. Sorry, yes, user-unfriendly. Yes and no. It depends on the service you're using. Some of them, like there's a console thing you can use, this web interface thing. It's pretty good, and they have iterated just over the last couple of years, like twice or so. So it becomes better. But again, lots of things is understanding how they work, how they operate, and what the mindset is behind certain things. That how a DNS zone actually works internal for them, and how they're using these IDs for different services and CloudFront distributions and so on. It takes a little bit of time to get into it, but there's lots of boilerplates you can just run, and then it works really, really easy. How big is the hassle compared to pushing to platform SH or Fort Rabbit? Like, very complicated to get up and running. When I first pushed it to Beanstalk, it of course completely didn't run because it's Symfony. You have to do the web folder, app, PHP, redirect stuff. But then I looked it up and it's like, oh, copy this, throw it in there, done. And it worked on the second try. The whole upload process is really that simple. Deploy, it packs it, it sends it, and that's it, and does everything else automatically. But you might want to do stuff around it. I don't even remember what we do around it anymore. We have a little script that does it now, but it's pretty straightforward. I can't say how Platform SH or Fort Rabbit is doing it, so I don't know how easy it is in comparison, but for us, it's very, very simple and easy. Okay, anything else? Going once? Okay, then that's it. Thank you.